Hello and welcome to the second video for section 11.1. This is the final video for this section. There's only two videos for this section. In this video we're just going to look at two examples. One with a parabola pointing up or down, one with a parabola pointing left or right. And we're going to use all that information we just learned at the end of the first video. So our first example is actually number 15 in the problem set for 11.1. We want to find the following. We want to find the focus, the directrix, the focal diameter, and then also we want to sketch the following equation. We have y is equal to 5x squared. So this will be a typical kind of problem you'll get in an exam. And what we want to do first off is look at this and figure out, just like we did with like the limacons and the hearts and the, well, I guess not so much the roses, but the limacon and the hearts, we want to look at the equation and recognize, oh, this is a heart that points up, or this is a limacon that points to the left. Things like that. First, try to get just from the equation, what should this look like? That way, as we start putting together the answer, we're kind of given a sense like, yes, this is what I would expect, or no, something's a little bit off. So first, because of this x squared, this tells me what? That tells me that it's opening either up or down. The value in front of the x squared is positive, so that means this is going to be a parabola that is opening upward. So if when I get all this other information in sketches, if I don't have a parabola that's pointing upward, I goof something up, either my estimation of what this was going to be or the actual math work. So first, let's write this in the equation or in the form that we had of our formulas in video 1. So we had x squared by itself. So if I do that, what do I have to do? I have to divide both sides by 5. So that means x squared is equal to 1/5 times y. So remember, in our equation, this value in front of y is equal to 4p. But all of my answers that I was given in the different formulas were related just to p, not to 4p, but to p. So I need to figure out what is p by itself. So if 4p is equal to 1/5, what do I have to do to get p by itself? I have to divide both sides by 4. So that means p is 1/20. So now I can start figuring out some of this information. First, the focus. Well, the focus was what? It's a point. We'll call it F. And it has what values? It has 0, and then whatever value I had for P, which in this case is 1/20. The directrix because this thing is pointing up or down, my directrix is going to be a horizontal line, so this is y is equal to negative whatever my value for P was. P is 1/20. So that means my directrix is y equals negative 1/20. It's a horizontal line running through that point on the y-axis. And then focal diameter, well, that's just the absolute value of 4p. Well, back here I have what? 4p is equal to 1/5. So it's just the absolute value of 1/5. It's basically absolute value of whatever we have in front of y. So this is just 1/5. Excuse me. So now if I have to draw this, so my focus, so we know that the vertex is at the origin. All the problems in this case, when we have this sort of formula, our vertex is at the origin. The focus is 0 units left or right and 1/20th up, so just barely above this vertex point, right? The directrix is just minus 1/20th down. And then the focal diameter is 1/5, so that means from my focal point, if I move out a distance of 1/5, that's the point that the parabola is going to go through. So you can see it's a very skinny parabola that's pointing up. And that's what we expected, a parabola pointing upward. So that gives us that picture there. So that's it. That's the example number 1. If you need to catch up on something, go ahead and pause it. I'm going to erase this, and we'll try another one. All right, so second example, this is problem number 21. Again, from section 11.1. And in this case, we want the same information. We want the focus, we want the directrix, focal diameter, we want to sketch it. Excuse me. The equation we have is as follows. 5x plus 3y squared is equal to 0. So the first thing we need to do is what? We need to put it in that generalized formula with our squared term on the left and the term to the first power on the right. So that means I have the y squared. So the fact that I have a y squared tells me what? This is going to be a parabola because x is to the first power, y is to the second. This is a parabola going to be pointing to the left or right. I'm not sure yet until I move the pieces around. So let me subtract 5x here. So I get what? I get 3y squared is equal to minus 5x. And to get y squared by itself, I have to divide by 3. So that tells me y squared is minus 5/3 x. So this value is negative. I know it's pointing left or right, so this should end up what? A parabola pointing to the left. So go ahead, pause it here. I want you guys to start getting in the habit of, when we do these examples, pausing it, trying to work them through, try it yourself. If you get stuck, then you can always restart the video, but using what we did in example 1, find this same information, focus, directrix, focal diameter, and sketch it. Give it a try, come on back. Once you're done, hit play, and we'll work it through. All right, welcome back. I hope you were able to get through this guy. So the first thing, our focus, well what? This is a point now. Because this is a parabola pointing over to the left, we're not moving up or down. So the y value is 0. Now we need our value for p. Well, just as in the first problem, we don't have p. What we have here is 4p is minus 5/3. So that means that p, if we divide both sides by 4, p is negative 5/12. So that means our focus is at the point minus 5/12 and 0. Now we need the directrix. So because this is a parabola pointing to the left, our directrix is going to be a vertical line, which means our x is equal to negative p, which is negative a negative 5/12, which means our directrix is at x equals positive 5/12. So all these negative signs here, please be careful. Focal diameter, that's just 4p, the absolute value. And we know that 4p was minus 5/3. So that means our focal diameter is 5/3, or 1 2/3, a little bit over a unit wide. And then lastly, the sketch. So our focus is at minus 5/12 and 0. So minus 5/12 is a little bit less than a half, and 0, so we stay right on the x-axis. Our vertex, again, remember, is at the origin. The directrix is at positive 5/12. So over here on the positive side of the x-axis. Focal diameter, again, was 5/3, which is about 1 2/3. So we have a little bit more than a unit. So something around there. And then it's just a matter of connect these outside dots. As you can see, it says sketch. Nobody's going to be sitting there with a ruler measuring, oh, they're only at 1 1/3, not 1 2/3. So the idea is, do you have a parabola pointing to the left, centered at the origin with these values? So that's it for video number 2. 2 different examples, one with a vertical axis, one with a horizontal. Obviously this is just an intro. Try the homework. See how far you can get. If you get stuck, make a little note. We'll work on those in the next class. Thanks. Come on back. We'll see you in video for 11.2.